I'm going to try to make this one quick, just kind of make it like an update, but there is a couple things that I was noticing after I went back and looked at a few things from my last live stream. So just kind of bear with me here. I appreciate everybody being here. Arizona, thank you for modding for me. Brittany, Vicky, Leonard, Shrimpy, Kelly, Willie, Glennis, hey, what's up? Susan, I think I said Willie already. Okay, guys. I am going to go ahead and get into it, though, okay? Alright. Yeah, maybe. Maybe we can. I don't know. Okay. So, Schumann. Again, guys, since my last live stream, it's only been a few hours anyway. So there you go. Not much has changed on that. But we will take a look at this over and over and over again. Okay, guys. Frequency touches everything. Well, everything is kind of frequency anyway. So there you have it. And so when the frequency's all messing, you know, just going a little bit, what we would call, you know, I guess abnormal. Not really abnormal, just kind of crazy a little. But it will affect us in some pretty good ways. So yeah, I would always keep that in mind. Ringing in your ears is the most common thing. In case you guys were wondering what you could actually feel from this, they pump this into all the space station, all spacecraft that have humans. They even pump it in for people that are that work underground in the mines and stuff. If not, they go crazy. The 7.83 hertz level. So yeah, so you got that now. Okay, Spaceweather, new prediction center. Obviously, the solar X-ray flux is actually kind of dipping down a little bit. I look for this to come back up, and I'll show you why in a few minutes. This is solar proton flux, doesn't really hardly ever move. And if you notice here, we took a pretty decent little bam. You know, kind of went up two levels there, all at once in the span of like a couple hours there. That's not in storm level. It's not a big deal or anything like that. But I will show you some hits on the magnetosphere. None of the other models were even talking about getting a hit like this right now. So we'll have to talk about that when we get there. First glimpse in the sun. These two sunspots are exiting off. Not quite yet, but they will. This one here is obviously the one that was giving us all the issues. Not really issues, just giving us some flares and stuff. This up here did a couple times, but you know, they survived pretty well, right? And now it looks as though they're going off the edge of the sun here, off the western limb, and they look to be just as healthy as they ever were. So we'll have to pay attention to that. You know, sometimes they'll make it all the way around a couple times. But anyway, as those two exit, we got these coming right back behind it. So these active areas, I would assume probably this one at the very least is going to be a sunspot, pretty quick like. You know, they probably already are, but we have to see it Earth facing for them to make it an official sunspot. This one here, probably pretty much the same. They both seem to be pretty intense, but you know, have to wait and see. Now we do know that this one here actually has some energy enough to fire some M-class flares. I've seen a report on that. So if it's holding that kind of energy, if it sticks around and it's not flaring or nothing yet, when it does flare, it probably will be pretty decent size. So that's what we got to pay attention to when they get out here in the front, right in front of us. That's really where most of the concern comes from. But also coronal holes, okay? That always, the coronal holes is what gives us our solar wind most of the time. It's when basically the atmosphere of the sun kind of peels back a little bit and exposes all that. And charged particles will just rush right out of there, and they travel on the interplanetary magnetic field lines, which is our connection to the sun, okay, and other celestial objects. But they always travel on that line. They're charged particles, so they're gonna follow a magnetic connection, and that's how they get here. It's not wind like most people think. It ain't gonna blow your hair back or nothing like that. Okay, that's just kind of a basic understanding of what that is. But anyway, the coronal holes is what we pay attention to a lot of times, because when they get right in front of the Earth, Even when they're not directly, we will still connect to it, and it will still send stuff our way. And you know, the majority of the time, guys, when we talk about getting like a increase in geomagnetic activity, you know, there's usually a coronal hole involved. Now, CMEs and solar flares obviously are more apt to come from sunspots. So, the ACE data, you know, this is the typical blackout. This is to be expected. This is what we expect every day. It's the line of sight from the satellite. It cannot, you know, I guess it can't transmit the data. At least that's the way I understand it. So, yeah, that's why you see that. But we can still look at the conditions there before and after. and obviously, whatever's happened in the past has already happened. So we're really a little bit more concerned about what's going on right here. Actually, this is all historic data, but this is the most recent data we have. So if you see right here, we have a little tick up in the speed. Now remember, over here we look at this, right? The range is 200 to 450 right now. So that's a pretty decent range there. Okay, it's not something crazy like we had been seeing. Temperature seems like it dove off a little bit. BZ is staying in the negative, which means that, you know, the energy makes it pretty easy to get here. So the phi angle, we don't know what it did here, obviously, but it seemed like to be pretty stable here. So as far as it doing its pole reversal that it does very often, we didn't see that there. Okay. Now, the Enlil model, again, guys, we're going to keep talking about this, okay? Again, I went back on there after my last live stream, and I personally watched this thing change with, you know, like 3 times in an hour. So this model is not confident at all on how high the density is going to be. And I know it's reacting to this because the rest of it is really low. So whatever that is that they're seeing, this model is not confident at all. So I've seen it get up to 25, I've seen it get up to over 30 earlier today. And it keeps changing because more data keeps coming in. And that's what it does. It will adjust itself. But I do trust it about 2 days out, and we're right here. So we got about a day, maybe 2, before that gets here. So keep that in mind when we're talking about stuff. So, you know, if this timing's right on this, we can expect a little bit of a hit when that gets here. And again, the solar wind speed, same thing. It's kind of going up here. Now this is what's kind of a little strange. This model hasn't really varied much on the wind speed. The only thing it's having problems getting right is up here, the density. So, you know, we probably will be pretty close to this wind speed, but, you know, how hard we get hit is going to determine, this is what's going to determine that, the density of the particles. And I've talked about that before. They're now learning that density is just as hard on the magnetosphere, if not harder, than just solar wind speed. The density almost matters more. But it's about a 50-50 thing, I think, in my opinion. I think the density may have a little edge on this, on solar wind speed itself. But yeah. So again, electron flux is pretty flatlined right there. Nothing much going on. You're going to notice over here in the Aurora one, this was a little bit more active than what we seen earlier. And it's because we're getting some hits on our magnetosphere, and I don't think it was expected. So it's kind of, it's caught me off guard just a little bit. You know, because we didn't see it on any of the tools, nothing like that. They weren't predicting any kind of increase in anything, really. At least none of the tools that I've seen. So you're seeing this kind of, you know, move around, and then right at the end, it's going to get really, really intense here. See that? And that's because we started getting hit. And if you look at the time, it was about 6 UTC. And it's ongoing right now. That's, you know, that Aurora, that's pretty intense Aurora right there. Okay, let me grab it and I'll bring it back to that. Okay, now what you're seeing here, guys, is nothing more than what it says it is. It's showing you the Aurora. It ain't showing you anything like particles or solar wind or anything like that. What Aurora is, guys, is basically it is the charged particles hitting into oxygen molecules or nitrogen molecules or whatever we want to talk about, depending on how deep it gets down into our atmosphere. This is showing you what we would see visually. So even over here, they're getting charged particles. It's just daytime over here. Okay, so you can't really see Aurora over there in the daytime. You know, so I think there is some daytime Aurora. Some, you know, every great once in a while, I would think it might show up a little bit, but I don't think it's a really common thing. At least not to us. And when we talk about Aurora, we're talking about, you know, nighttime stuff that's really cool to look at. Okay, this is ISWA, obviously. I'm going to talk about this this right here. There's that coronal hole. Okay, they're starting to map them out here. I do think that this is probably going to open up a little bit more, in my opinion. If it does, it does. If it doesn't, it doesn't. I'll tell you either way. So, again, stereo A and LASCO C2. These are the two tools that we see over on seeds. You know, the one here on the right comes from Soho. It sits out in front of the Earth, looks at the sun always. Stereo A is on the side of the sun. So basically, stereo A is here, and the Earth would be about right here. Okay? And if you wanted to do that over here, it would look like this. The Earth's kind of like right here. Stereo A, kind of like right here. Okay? That's the difference. It's millions of miles away from us, guys. Okay? So, yeah. Again, you can see how these sunspots are... And what was really strange is if you drew like an X... It's just crazy. It's just something I noticed earlier. And it doesn't mean anything, guys. All it means is it looked kind of crazy. You got a smaller sunspot area, a smaller sunspot area. Go that way with it, right? Then you got the two big ones kind of like right here. They are pretty much on the same latitude line on the sun. It's kind of strange looking. At least the way that these are exiting and coming into view is what I'm saying. So yeah, I'm just trying to look here if there's anything to see here. It did look like it might have did something there on the end. Yeah, it probably did right there. It almost looks like there's a filament going on right here too. Let's zoom in on that real quick. You see that right there? That's probably an ejection. Let's watch that. I bet there's a flare with an ejection. Kinda. It might not have left the sun, though. It looks like it might have, though. I'm not really 100%. But regardless, guys, that wouldn't be coming at us. That would be going the other direction. So let me move this back over here. Yeah, so I'm not really seeing a whole lot there, guys. So there's the 171. You can see that. I'm going to pause this and we will. So you can kind of see how all this is still very, very busy. Okay? And I'll show you on seeds here in a minute. We had another ejection. Not a very big one, but actually it showed up on stereo A too. At the end of the day, watch this. It's going to kind of shoot out right here. See that? So, yeah, something, it looked like it might have could be coming our direction, but it would still take it 4 or 5 days to get here, guys. So we got time to wait and watch and look. But also over here on Soho, our view, and it kind of does too. Looks like maybe you had something go that way, so it could be missing us also. So again, we got time to wait, see if more data comes in, and we'll talk about that at that time. Let me zoom in here one more time. I'm trying to get this through here, guys. That way we can give people that want a quicker video something to, that they can do that with. So I will take this and we will. So yeah, I mean, stuff is still leaving the sun. It's not really big right now, okay? It's actually kind of quiet. If I had to say, other than the sunspots themselves, they always give off X-rays anyway. We're going to come back to this down here, okay, in a minute, because I want to show you guys some stuff that's actually kind of strange looking to me. And again, we'll take a look at that in a second. Let's go here to the Magnetopause models. These are reacting right now. Look at all this pressure, guys. So we'll talk about that too. I don't think any of this was really kind of expected, just so you know. I didn't see anybody talking about any kind of increased geomagnetic weather effects on our planet or whatever today or tonight. So this is coming from somewhere. And what I will say to this, guys, is that if you notice, we're not really seeing much of an increase in speed out in front of the bow shock. So, but we're reacting pretty good back here. And things are moving from left to right like it would if we got hit with stuff from the sun. But it's just kind of odd that we don't see any speed increase at all this direction. Because this is showing you speed. So usually if there's like a wave of charged particles coming, they'll come at either a faster or a slower speed. And, it doesn't necessarily mean we're not getting stuff from that direction. It could be just it's all traveling at the same speed. But density isn't showing anything either. So two things would have to happen there. The density would have to be the same, and so would the speed. And I kind of find that a little bit hard to wrap my brain around, because why are we reacting if everything is staying the same? It just shouldn't, I guess. I mean, I guess that would be the answer to that, but we're clearly reacting. And we're reacting in a way that's actually adding pressure around our planet. So this is something that isn't like glaring people in the face, but something's going on here. It may not be no big deal. Most likely it's not, but it is something that we need to look at, because I wonder why. Why is this happening and we're not seeing anything? Again, we're not even seeing the pressure one show any kind of, difference out here in the front. I find it really odd. And again, things are moving from left to right. So it ain't like we are catching something from directly or down here or anything like that. It doesn't look like that. It doesn't look directional or anything. I just don't know where it's, what is actually causing this. But something is. So what I'll do here, and just to show you what I mean by this, that with that, what we're seeing there and this going up at the same time means that something's going on there. Means that we're getting some geomagnetic activity from somewhere. Where's it coming from? If it's not coming from the front, or at least a good enough increase that we can say, hey, yeah, look. Because look at the A data, guys. It stayed pretty steady. Nothing much changed. So I'm not confident in that. I don't know what's going on. So we'll look at the Australian model. This is on the 31st. And I'm looking at the density here. And it's going, that's not too bad. It's staying right around the same. Right around 6, 7, 5. We are staying in the negative on the BZ, though. That does increase our chances of energy. So, I don't know what to say there. Our wind speed, it didn't do anything. Watch. Right here's the wind speed. that should be typically between 300 and 500 is what we would consider normal almost. And it's not doing hardly anything. Everything just looks really, really normal. But then when we look at this, it's not. So I really I don't know what's actually happening here. Okay. You know, and again, I can't go to one spot around us on our magnetopause or anything to tell you that it's coming from down here, here, wherever. I can't do that because everything is actually, you know, kind of doing something here and then shooting off. So I don't know if we've been collecting a whole lot of energy like we do as a capacitor and just releasing it out. But I don't see that, and I'll show you what I mean here in a few minutes. But this here also is telling me that we're getting hit with something, because this is actually reacting too, and it seems to be up here in Canada is where the center point would be, and that makes sense because we caught a weird earthquake up there just a few hours ago. I'll show it to you real quick. Right here. That was a 3.6 right there. It's what did it say, 35 kilometers west-southwest of Amos, Canada. Okay, so obviously I'm not the earthquake guy, right? I'd be talking to Ricky or Ron Tyler and Dutch and everybody like that is who I go to, right? Obviously this just happened at 5 UTC, which would have been about 5 hours ago. Okay? Was that 5 or what time? No, it was at 1400. That was on the 30th, okay? I didn't see this earlier, so I'm just kind of curious on what that was. So, they may have talked about it. Maybe I missed them talking about that. I don't know. But I didn't hear anybody else talking about it, and I noticed it, so I figured I'd bring it to you. Something else, though, too. If you look here, that earthquake was at 48-degree latitude. These over here were at about 37, 38 degrees. And you get a bunch right around the same, latitude line. Just kind of right there. Let me change this to all quakes, and you'll see what I mean. And again, it probably means absolutely nothing, okay? So, but we are getting more earthquakes there. There's a 5 up here. There's a 5.3. Now, if I show you the Helioplots, every one of these things is going to show that it reacted, and it's because of the big quake over there yesterday. Okay, in Greece. If you look at the timestamp, they most definitely would tell you that. It rung the whole planet pretty much. Okay, and we see this, right? But this is nothing like what happened over there in Alaska. When that one went off, these things went solid black. And Ricky was trying to explain to us it was the low frequency that it was picking up. And how odd that was for it to do it like that. I don't understand these enough to kind of go into that kind of a detail, but I will show you this because it does give you a pretty good visual that, hey, when we get big earthquakes like that, something rung the whole planet. Or when it moved, it rung the whole planet, that kind of thing. So let's go. Seeds. I'll take you here to the most updated one here. And you're going to see, like I said, you're going to see little CMEs. There's that one that popped off out here and here. Now, something you're going to see here is we don't have anything on the 31st yet on LASCO C2. But we do on Stereo A. Now, remember, this isn't the only place this data is being shown. I just showed you guys over at ISWA. So, the data isn't necessarily missing. But I did see it was missing on this one and on ISWA. So it could be not there at all. When you start seeing it like that, and why was it missing data? Who knows? I will say this, especially like on Stereo A, it took a blast yesterday, if you guys remember. Let me, I'll show it to you again real quick. See this? Remember that CME got fired right at it? That's what it was. Okay, it just took that hit yesterday. So, I guess maybe, you know, that could have been why we're missing some data on it. Because we're missing some pretty decent amount of time on that. Let me bring this back and I'll show you. We're missing about the first 12 hours of the day. Well, about 3 to 13. And then it shuts back off around 17. At least on this one. But over on ISWA, I know it's missing the first part. But as far as the last part, I'm not sure. But you can see this now, right? So whether that's coming at us, I don't know. I don't know yet. Have to wait and see, get some more data in. Even if it is, it wouldn't be that big of a deal. And, you know, because it's not that big, it doesn't look to be real powerful. You can tell because the real big and powerful ones definitely show up on the red really, really massively also. So we're hardly seeing it over here at all. Showing you the sunspots again. Those two are rotating off. I look for these other two. Okay. Now remember, they've taken the sun and turned it on its side right here, guys. For anybody that didn't see my video earlier, that's what you're seeing there. Okay. We will go down here and check out the fireball situation. We've had 9, which is pretty low. Okay. Near Earth objects, meteors and stuff that fly real close to Earth. Not much going on. Okay. Today's the 30th, so there's going to be 1, and it's 11.5 lunar distance, which is 11.5 times the distance to the moon. So it's, you know, they call it near Earth because they're taking in consideration how big space is. But, you know, to us, that's a crazy amount of miles, just so you know. Yeah, we're talking in the millions of miles there. So, yeah. But, again, you know, we're looking at this, and if this holds true, which I doubt if it does, because it will change, they'll find more probably. But all these other ones here in November look to be pretty, you know, far away. We've even got one at 20 lunar distances here. Okay? I'm not sure where they max that level out at when they start calling it, when they don't, like, consider it near us. I need to find that out. But something else I've been talking about, you know, the year of the sun cycle we're in. This was the end of that our last sun cycle, 24. This is going into 25, and with the increase in activity is now 10% from that year to that year. And if you compare it to the last sun cycle, it's only 2%. So right now, if the year was to end today, that would be an 8% faster increase into more activity. And in my opinion, that's not the best thing for us right now because obvious reasons, guys. You know, our magnetic field is weaker. So we don't want as much activity, just to be honest. Okay, I'm going to pull the chat up here real quick just for a second. Make sure everybody's okay. Everybody in there? Give me a thumbs up, guys, if everybody's okay. Hey, Becca, Christine. How you guys doing? All good? Okay. Cool, guys. Cool. Hey, Hilly. How you doing, bud? Axe, Cheryl, Eli. All right, guys. I'm going to put this back away because I want to get into this. And I was looking at this, guys, and again, I'm seeing stuff I've not seen it do before, and usually, you know, when we see the crazy stuff on this, usually it's behind us. I'm seeing stuff out here that's it's freaking nutty. That's what I'll say. And I'll try to explain what I mean. Not sure how good of a job I'm going to do with that, but we'll see. Now, to give you guys a base of what we're actually looking at here, the blue lines are the interplanetary magnetic field lines. Simply put, they're our connection to the sun and to other celestial objects. So when those things are getting all moved around and doing this and doing that, that's our connection, right? So we got to keep in mind of that. The red lines here are closed field lines. Now the black lines are our pole lines. And they, comes in north and south pole, obviously. So when I start seeing crazy stuff, I have to stop, right? So if you look out in front, you can see we're getting a little bit of a wave here in the front of energy. Now watch these interplanetary magnetic field lines. In a perfect world, okay, or universe I should say, at least at that, these magnetic field lines should stretch straight up and down. That's it. They should look almost like a vertical line straight. Now that's if we lived in a perfect world. Obviously we don't, and this is what happens when we're getting hit magnetically, right? We know it's not going to stay perfect. There's nothing jacked up about that. But what I do see here is what's actually happening. So if you see this line here, you're going to see, okay, you can actually see that wave hit and it go on out the back, right? So then we stop here and we look and we're like, that's kind of strange, right? Now then we start seeing this stuff. This is where I stopped and I was like, what in the world's that? This is this is our connection to other celestial objects and the sun. It's supposed to be. So why is this one out here by itself looking like a pretzel? I don't know. But watch what it does. Now we've seen it do that before. I've seen it do that before. So, and it's going to do some other stuff here in a second. Alright, now do you guys see where the weirdness is coming at here? Now, I want to stop there too. Do you see, look where our pole lines went. Why? Why did our pole lines go out so far that it looks like in front of us, okay? That shouldn't really be happening. These pole lines should go up and go out the back like this, okay? So this is out here in the front and almost past our bow shock. It did not make it past our bow shock, but it looks, I mean, it's there. Look at that. So I keep moving and we start seeing this crazy stuff. Now I'm not even going to talk about this stuff because, yeah, we'll talk about that in a minute, but watch out in front. Look at that. And then that. I mean, now remember guys, this is a two-dimensional model trying to represent something that's three-dimensional. So the fact that these field lines are actually moving, they look kind of arced like that. They could be, if you could picture this, if you seen a line right here and you grabbed it right in the middle and you pulled it straight to your face and then rotated it, that's really what we're looking at. Okay, as you just move forward like that. I know it's kind of hard to understand, but that's what we have to try to do. It's more like a half donut around our planet, and we're in the middle of it. That's more what our magnetic field looks like out here. Okay. So we do that. Now look at that. Okay, something has pushed the magnetic field lines out here, clumped them together, and they're just piling up right here. Look at that. So I keep moving, and then all of a sudden they flush out. What is that? And they stay twisted like a pretzel. Look at that. I mean, if you thought I was kidding when I said it was a pretzel, look. I mean, it's not connected to nothing. That's by itself. And it just keeps happening over and over and over again for a few hours. Okay, and I know you guys seen all those closed field lines getting stretched way out here. That's strange too. I mean, we've all seen it do that before. I've not seen it turn into some stinking pretzel out here in the front, ever. I've seen it get all jacked up and go kind of directional. I've even seen it pile up like I showed you a second ago. But I've not ever seen it do like a twist in action like a pretzel on both ends. I've seen what looks like it's kind of like spinning, but I've not seen it like that. See, watch out in front. Watch this. It'll kind of spin. See that? I've seen it do that a lot. But then we look out here in the front again. Okay, and then yes, I know you guys see that. That most likely was, you know, like I said, when we get something like that, we had to get hit in the front. Okay, now the other models, like I said earlier, are not showing any kind of speed, nowhere near you know, there was 1,000. It was like 1,400 I showed you guys earlier. Okay, it must be back here. Anyway, you guys seen it, right? What's the timestamp on this crazy looking 22? Let's go over here and I'll show it to you real quick. And there it was. Okay, 1425. You know, that's fast, guys, okay? And for none of the other models to show any of that, including this one. So, if we're... That's it on the 30th. Let's go over here and look and see what the Australian model shows on the 30th. Let's watch the speed. Let's see what it says. This gives us a reading every minute. Staying right around 400. Yeah, it's not coming out of 400s right there, guys. And this thing is giving us a reading every minute. Okay? This one here gives us a reading, I think, every 4. Is it every 4 minutes? Yeah, roughly every 4 minutes. Okay? So, I don't know what to do with this, is what I'm trying to say. Because I got one model telling me things are just freaking flying, and then I got another model saying, hey, no, things don't look like that. So, what do we believe here? What do we look at? What's the right thing to do? Right? I don't have a good answer, guys. And I'll take this one to the same area because I seen on the. Keep in mind, all 3 of these are getting their data from the exact same place. So, and the modeling's coming from the same place too. So, chances are, whatever kind of crazy stuff's going on with any of these other ones could be going on with this one too. Okay, so let me get it to where. Now, did you see us react right there? Now, look at this little, like, bubble of whatever, bam, getting ready to go out the back. Okay, it's showing like we've been getting hit with something, but I can't tell you what that is, so I don't see it anywhere else. Nothing else is giving me that kind of data anywhere, so I'm not sure what to say or do here with this. What I can say is, if this is correct, that pressure is close to our planet. Okay, it's not real heavy right there, but it was back here. See the red and yellows and stuff, greens? And again, I'm not seeing a whole lot just kind of bouncing off the front. So I just don't, it's hard for me to wrap my brain around what's actually happening here. And, you know, even at the most recent capture, it's got us doing this. And then you get this, and then the only thing it's kind of saying, hey, this thing might be halfway right, is this. Right here. We had an uptick in geomagnetic activity. So I don't know where to go with that, guys. You know, is it a big deal? Well, it kind of is to me, because I want to know which ones we should be looking at. I want to know what is going on, which ones we can trust, which ones we can't, all that kind of stuff. So yeah. So Julie, oh, that's a good question. You know, guys, it's hard to. Okay, we can. Yes, we've done it before, but the fact of the matter is, we just don't know how many's actually out there. We don't know what it's actually made out of, any of that kind of stuff, right? Hey, Sid. So that's where I'm at. Yeah, I don't know, Steve. Yeah. So yeah. It's not about understanding what the model's showing us. What it is it's understanding that the other models, they're contradicting each other. That's my thing. So, and that is, that's one thing we can do. We can just research the crap out of it, but the thing of it is, are we researching with the correct data? That's the big thing I'm talking about right here. Because, like I said, guys, the data we're getting for those models, they're all coming pretty much from the same place. So you got one model showing something, and you got another model showing another, and they're like way crazy different from each other. So, I mean, that's the thing I'm talking about here. And I don't want to have to figure age of the model into it, because I don't think that's always the right thing to do. But the one that's been out there forever is the one over on ISWA. It's been there for a long time. I'm not sure how much they've updated its modeling. As far as visually, they haven't updated it at all. But maybe they do figure in different stuff now. I don't know. But like I said, I have no idea which model to look at on that kind of stuff. I don't see how we could say that one of them's right and the other one's not, when they're both coming from pretty much the same place. It's kind of, like I said, I don't know what to think on this part of it. So, yeah, guys, I mean, so this is extremely interesting. You're learning slowly, common sense, and Todd, it is. And guess what? I've been looking at this thing for a long time, and I still don't completely understand it. There ain't nobody out there that completely understands everything. I promise you that. It's hard when we're trying to show people things, and you show them observation after observation after observation, and that's all we got, is what I'm trying to say. So I don't know. Yeah, I don't know, Eli. That's the thing. That's kind of where I'm stuck at. It's hard to hang your hat on one model or the other. And either way, I just want to know which one to look at. That's kind of where I'm at. Eventually, they're probably going to take them all from us. That's what's going to happen. I mean, there's reasons to believe one, and then there's reasons to believe the other. There's a lot of different lines of thought there, I guess, if the newer ones, I don't know how they built the model. And I would never be able to know, just so you know. I'm sure that, and even the old ones, they figure in so many things that a lot of us, including myself, would not have any idea what it actually means. Yeah, Eli, I get that, but something you're leaving out there a little bit would be the fact that they could take that same model that we're looking at, that have been forever, and change it too. It would be the same as doing anything else. They can change whatever parameter they want in those models, and we'd never know it. And, you know, that's kind of what, that's where I'm kind of like all over the place with this. I'm sorry I don't have better answers for you guys. I really am. I just thought it was really strange because I'd never seen those IMF lines get turned into a freaking pretzel in front of us. Now, we've seen it, strange stuff. We've seen all kinds of crap out in back of us, okay? I mean, all kinds of crazy looking stuff. I've even did videos on it. Eli was talking about Eric Briggs. He's done a lot of videos on that. It's, you know, that's what I'm saying. And what I'm saying, talking about this, is which one do we trust? That's my big thing. I'm not even trying to actually figure out what it's actually showing me. And the reason being is because I don't know which one's true. So I'm not going to, like, say, hey, this is happening on this one. You see what I'm getting, guys? I really do. I wish I had a better answer for you guys. Yeah. Yeah, it is available by, you know, it has to be because we pay for it with our tax dollars. That's the only reason why we can even look at this stuff. I guess the only thing that we could actually do, guys, if we really wanted to get, like, really down to it, is forget the model and go get the data that they use on the models. And then if somebody was smart enough out there to be able to build a model, I don't know. I could never be able to do that. Because essentially, that's what's going on. You know, like when we go to these other sites, guys, I want you to understand that when we get these, show you these models, these are from different people. These are from different, like, universities, different agencies. Oh, I don't know, Eli. That's what I'm saying. But I would assume they would have to give that to us. You know what I mean? Somewhere. I've just never dug that far into, like, getting the original data because I wouldn't know what to do with it. I couldn't put it in a model. I wouldn't even know how to do that. It's going to take somebody with a lot of knowledge there to be able to do something like that. And I don't have that. and you know, like I said, a lot of these universities, they use their students to do this kind of stuff. And, you know, they all build models. That's why when we look at these models, they all look different. As far as visually, they might be showing us the same thing, but the visual is always different, just a little bit, even if it's a color here or a color there or whatever. You know, another case in point would be when I show you guys the sun pictures. On one site, 171 angstrom is yellow, and then on another, the 171 angstrom is blue. So that it's still showing you the same thing, it's just a different color. Thanks, Eli. I appreciate that. I just don't know what to do with that. Yeah, Chop, I mean, that's the thing too, guys. Even as long as Scott and Dutch and everybody else has been doing this stuff, I mean, it would take a lot of knowledge to be able to take that data and build a model, a computer model that would be able to be accurate in any sort of way. I wouldn't even begin to try to understand all of that and get any kind of correct. You know what I'm saying? It's just really, you know, like I said, building a model almost takes a degree. I hate to say it like that, but it does. I don't have any kind of knowledge on that. I get really frustrated, guys, when I look at this stuff and I see two different things on two different models, and then when one will actually contradict the other in one area, and then the other one will contradict the other one in a different area. And if you look at all of it as a whole, you know, I don't know. So, tilting or while, yeah, guys. I mean, that's another subject with the Earth tilt and all that, and it does tilt. We do have a lot of tilt going back and forth, you know, and that's the other thing. You know, we don't know how far we're tilting. Because it does, believe it or not, guys, it does vary sometimes. You know, I think we would be, I don't want to say, you know, I think we would be like not as thorough if we didn't try to figure out what that was actually about. And how we can understand that it does move in ways that we didn't think that it could, and not really affect us like immediately. You know, there's a lot of stuff there. And it's like this, guys. You know, when you guys first came into the community, just kind of think back, for myself too. When somebody told me pole flip, you know what I thought? And most of us probably thought this: geographic pole flip. What that means is the geographic North Pole is an actual fixed position. Okay, and so is south. It's like Santa's North Pole, right? Big candy stick up there. Well, when we're talking about a pole flip, we're talking about magnetics, not a geographic pole flip. And most of us think that way. Anybody that doesn't have knowledge of this at all would walk into our community and think, my gosh, the Earth's going to turn upside down. You know what I mean? And they would be okay to say that. You know? It's just kind of crazy. Yeah, I mean, I think I understand the field lines pretty decent. I'm not going to say I know just as much as Scientific Lee does. I've never seen his channel, so I mean, yeah, I'll go check it out. I've never actually been to his channel. I'll definitely go check him out. Yeah, that I do know. Yeah, I mean, it's definitely something that you can, like, if you get magnets and stuff, if you're in the right condition, you put some lighting on it, the right kind of lighting, you can actually see it, even right in front of your face. And that's the thing, you know. Yeah, we got to understand the Earth is a magnet, guys. Magnet, capacitor, all kinds of stuff like that. It releases energy just like anything else. And that's why when I see stuff doing things, I'll often wonder if it's just like that. So, yeah. Yeah, I don't know much about the moon thing there. It does seem to be like it's moving this and that all over the place. I wouldn't, you know, like I said, I've never researched that enough to actually kind of, like, have an opinion on that yet. I know a lot of people have had. Well, we were just talking about Eric Briggs. He's been talking about the moon and field rotation. How he thinks it's not really field rotation; it's rotating way more. And I don't know enough to even give him any kind of opinion on that. Really, I just don't. I've just not researched it, but. There is a lot of information, guys, you guys can go out there and get on your own. And even if I did think I knew what was going on, I would still not speak in a definitive way, because I wouldn't want to influence your guys' thought patterns at all. I just want to show you observations and all that kind of stuff. And that's why I showed you all those models at the same time. And that's kind of what I'm saying, you know. I want you guys to be able to understand the model. That's really my goal, guys, okay? And I still don't understand some of them all the way, and when I don't, I'll tell you that. So when I show you an observation on a model, that's pretty much where I want to stop what I'm doing, because I want you guys to be able to see it, kind of go do your own little research if you need to. I do a lot of research on stuff too, and I bring it to you guys when I do. But at the end of the day, I will show you an observation, and you can make up your own mind. And I'll tell you my opinion, I'll tell you my theories and all that kind of stuff too on top of it. But I still want to leave it open enough that I don't want to be the person that points you one direction and then I'm wrong. Does that make any sense? Because people have done that to me in the past, and they were wrong. But the difference is, I'm going to come out here and I'm going to tell you I was wrong. There's been a few people in my life that did that. And I'm not even talking about, this research stuff. Just in general life. That never came back and told me that they were wrong. You know what I mean? So, so I'm almost certain there's another binary system parked out there. Yeah, probably. That, you know, guys, I mean, there's a lot of different stuff going on out there that we just, you know, again, it comes down to observations for me, guys. If anybody watched my last live stream, that's exactly kind of what I was saying when Scott showed me those pictures, and it's where Scott's at too. But I never said anything hit the earth, guys. I don't know. I've never said a planet or anything like that hit the earth. Like when I say in my thumbnails, like magnetics, you know, something hit our magnetic field. Yes, we're talking about magnetics and like whatever else going on there. But, oh, it's okay. I'll answer him. That don't matter to me. So, yeah. What predictions? Nah, I'm not going into no predictions right now. Hey, OU, how you doing? I ain't seen you in a minute, Jeff Davis. Good to see you. Yeah, or like Paul did it just said, like CMEs when they hit us. I've never ever said nothing's hit the Earth. No, I've never said nothing was ever gonna. I've never even hinted at something gonna hit us, like physically hit us. I've never ever said that. I know you have, OU. That's cool, Jeff. Yeah, I mean that's what we have to do, you know. Isn't this a prediction for new? Not out of my mouth. It hasn't been. Guys, let me tell you something. You're never ever going to hear me say that anything is going to hit the Earth. Okay, as far as physically hit our Earth, I've never said that, and I never will. Because, you know what it would take for something like that to happen? You know, if we're going to take in consideration like magnetics. Yeah, I'm doing okay, Jeff. Objects are going to come. You know what happens? Usually they repel. That's why, you know, like when they're doing particle colliders and things like that, that's why they got to get them moving at such a high speed. Because they're trying to repel each other most of the time. You know, but then we have to figure in forces like gravity and all that other kind of stuff when we're doing, you know, when you start talking about space. But I have never. Yeah, well, yeah, okay, yeah. Let me. You know what, Jordy, you're right. Things do hit us like little meteorites. I'm talking like huge objects. You know, when people talk about like quote unquote Nibiru or Planet X or whatever we're talking about going to hit the Earth, no way. That ain't happening, guys. Okay. Just saying. I don't think it. Yeah. So. Oh, he's referring to a CME inbound on the 2nd. Yes. Yes. That. When we're talking about CME, what was his name? I forget. Anyway, if he's still here or she, we're talking about charged particles and plasma. You know, that's what we're talking about. And it hits us magnetically, typically. And that's why it would affect our electricity. It's like a big, gigantic EMP if it was to make it through. That's what it would be like. Yeah, Watchmen, you should. 100%. That's exactly what I want you to do. Don't believe me. That's exactly what I want you to do. Don't believe me one time. I mean, seriously. Go look at it. That's why I'm trying to, you know, like I said, when I show you guys things, that's what I'm talking about. I'm showing you guys an observation in hopes that you will, you know, make up your own mind through your own research. And, you know, yes, take in consideration what I'm showing you, what I'm saying, and what everybody else is showing and you're saying. Yeah, you're right. Well, I do. That's okay. No, that's, you know what, you know what, Eli, you're right, and I know that, but you know how we handle that here, and that's if they're vulgar, they're out of here. If they attack somebody personally, they're out of here. Other than that, they can stay, even if they are trolls. Oh, talking about when the Earth absorbs energy from the sun? Yeah, a lot of that comes in through the poles, which is when I was showing you those black lines on that one model. That's why that's so important. Because if it's coming in easy on those pole lines, I mean, yeah. Yeah, we've had major CME events happen. Of course, the one that comes to mind most recently, or not recently, but most prominent, would be like a Carrington event. So you guys can go, I've talked about that before. If you look up Carrington event, you'll get your information. So, even we had the one back in, I think was it late 80s, early 90s, when the grid went down, and like a quarter of the grid in Canada went down because of a CME. Actually, Stella, you're exactly right, but there's a lot more that happened after that people aren't unaware of, that did some damage. Like I just said, that whole grid thing up there. You're right, Eli. It's not a doom and gloom thing if you understand it. It really is. It isn't. We just got to be, prepared. And if we do get that quote-unquote Carrington event, just have some stuff here at the house for when the lights go off. That's about it. Because it could, if something like that was to happen, or something bigger, if we lose electricity now for the extended period of time, which is what would happen there, that would be really bad. They estimate 90% of the population would probably not be here because of that. Because people just simply don't know what to do without electricity anymore. Now, that number would have been a lot lower if we'd have been talking like 18th century. So, Yep, we do. We build up energy and we expel it. That's why I use the word capacitor. That's exactly what a capacitor does. Thanks, OU. Thanks, Jeff. I really appreciate that, man. Thanks, Frank. I try, guys, I really do. My mods are awesome. I mean, they really are. And I do try to have a lot more leniency than what a lot of other channels do. And that's okay. Okay? I don't, I'm mods for other people too, and I respect what they want me to do on their channel. And my mods have extended me that same thing, which is awesome. And, they're going to talk to you guys. They're going to, they're just nice people. I try my best not to be judgmental. And I think, hopefully I've shown that throughout my channel. I try my best on that. I don't want to put somebody in a category that they're not. I don't want to give you guys information where it could possibly be wrong. That's why I don't speak in definitives when we're talking about stuff like that. I'll show you my observation, give you my opinion. I know I sound like a broken record. I've said it 1,000 times. I need to quit saying that kind of stuff. Like, come on, man. So, yeah, guys, I am going to go ahead and cut this. I really didn't even want to go on this long, but it did. Oh, well. We will go with that. Starting Monday, guys, I'm going back to my recorded videos for sure. My wife goes back to work then. That's why I haven't. I know I said I was going to already, but I couldn't for other reasons. That's why I didn't get to do a video yesterday until real late. I'm trying to, take care of my family first, But I will be going back to some of my recorded videos. What I'm going to do, and this is my plan, and I'm going to make sure that this happens. I will do a. Thank you, Eli. I'm going to do a video in the morning okay, and I'm going to post it. It's going to be like a 30-minute recorded video. I was going to try to do that today with you guys here, but this is what happens because I like you guys so much. Oh, man. Yeah, I could probably do that one of these days, Hillbilly. Yeah, for sure. I would do that for sure. For sure. So, you know, so I'm going to do a recorded video in the morning, and then I'm going to do a live stream probably around 9 or 10 o'clock at night. You're welcome, Sid. So that's where I'm going to be, you know. That's probably what I'll end up doing. Do you have the time to show the southern hemisphere aurora ring? I wouldn't even know where to go to get that. I'll do some research on that, Paul. And you know what, bud? If I could find something to give me a model, I will start showing it for you, for sure. Because I think it would be, number one, I think everybody, believe it or not, could benefit from that. Because then we would be able to see what kind of charged particles are coming in on the South Pole, too. Thanks, Les. Appreciate that. Yeah, I'll try to see what I can do. Back at you, Susan. Thank you for being here, guys. And all my mods, I just can't say enough good things about you guys. I really can't. It's, you know, believe it or not, you guys have helped me more than I've ever helped you. You guys kept me out of a lot of trouble. Just put it to you that way. Kept my mind busy so I wouldn't fall back up into some old bad habits. And anybody that's been here for a minute knows what I'm talking about. So, you know, if anything, I'm indebted to you guys for doing that. So, I know you guys didn't know, but, you know. It's on the solar ham on the left underneath the models. Okay, I'll check it out. I will check it out. So, yeah, guys, I am going to go ahead and get off here. So, God bless. Have a great day. Go visit Hilly. He's got he's done a Bible study here in a little while. So, go check him out. I will, guys. God bless. Yahuwah saves. And, yeah, Jeff, you can still drink this blue Kool-Aid like you just said, brother.